Hello everyone, my name is Janpam Singh Sekarwal and today we are going to talk about this is actually our third video on relation and function. In first video we have talked about the Cartesian product. In second video we have mainly talked about what is a relation, and this is the third and last video on this topic in this chapter. And in this video we are going to talk about the function. What is function, some functions and their graph, and algebra of real function. So these three things we are going to cover, right? So first of all, what is a function, right? Function, there is some function of something, means something is running. There is a function in mobile, in a car. So function in a general terms is like something we are doing a work, right? Something logic. Function means something logic, right? So here also we have a function. Okay, so see here you can see it's written relation, right? Multiple outputs, and here function single output. What does it means? You see here this x is called the input, and this y is called output. We are talking this about in the context of relation and function. So x means input, y means output. If you put 1 in input, you will get 4 and 6. If you put 2, you will get 4 and 6. If you put 3, you will get nothing, right? So this is the relation world, okay? Relation jindagi, aam jindagi. But in Mentos Jindagi, I hope you know about the Mentos Jindagi. So when you talk about the functions, so there is something very different here. And what is that difference? That if you put any input, suppose we have an input 1, so there is a single output for this, okay? If you put 2, there is single output for this. If you put 3, there is single output for this, right? So let's see in next slide. So relation and function. In relation there is multiple outputs. In function there is single output. So we can say that the function f from a to b is denoted by f such that a arrow a to b. Okay, so in function there is input 1, output also 1, right? So you see here we have a set a and set b. If we put 2, we are getting 2. If we put 4, we are getting 2. If we put 6, we are getting 6. So for this one input we have one output, one input, one output, one input, one output. So this is a function, right? In this example, this was our first example. In the second example, what we see here is there is one input 2, and for 2 we have two different outputs. See, we have 2, and for 2 we have output 2 and 4 as well. So this is not allowed in function, okay? For the second element, yeah, there is one output, okay? For the third also there is one output, but for this one, why there is two outputs? So this is not a function, okay? This is not a function. Not a function, right? I think I have done something wrong. I have written relation. This we are talking about function. Okay, let's see. So I hope you have understand. This is very simple. In function this is allowed if you have two outputs, right? In relation it's allowed if you have two girlfriends. But in function this is not allowed. There should be only one girlfriend of yours. Yeah, but the girlfriend can have two boyfriends, no problem. Okay, suppose this is a boyfriend and this is the girlfriend, or vice versa. Okay, so if 2, 4 and 6 is here, and suppose 1, 2 and 3 is here, so boyfriend is allowed for only one girlfriend, but this girl can have two boyfriends. Okay, or we will just cross, we will write GF and BF. Okay, so anything you can imagine as per your convenience, no offense. Yeah, so here you see GF is strict to have one boyfriend, but boyfriend can have two girlfriends. Okay, so in function we can say that in function image, in function we can say that image can be single function, right? And pre-image can be multiple. Okay, or you can say the input, the output, no, yeah, that is fine. In function the image will be single. Okay, what is image? For this one, 5 is image, so for 1 there should be only one image. Okay, but for this 5 there can be more than one image. I hope you understand. Let's see the examples here. Example 10, let n be the set of natural numbers and the relation. Let n be the set of natural number. Okay, set of natural number, this is n. Okay, this is n and this is set of all natural numbers, so it will be start from 1, 2, 3, 4 and so on. So number and the relation r be defined on n. What is n now? A set of all natural numbers. What is r? The relation such that r equal to xy. So the relation r equal to, we will having a set order pair elements. So there will be x and y such that y equal to 2x, x y belongs to n. What does it means? Okay, let's clear this and try to understand again. Let me clear everything I have to clear now. Yeah. I don't know why I'm doing this stupid thing. I can erase this with a very utilized method, but okay, no problem. It's saying let n be the set of all natural numbers. Okay, so we have draw a set and 1, 2, 3, 4 and so on. Okay, this is called n, right? And the relation r be defined on n, means we have to make a relation on n such that r, this relation should be x and y. Okay, so in this relation there will be x comma y, xy such that y equal to 2x. Okay, y, what will be y? This y will be 2 into, so if we just remove this y and we write 2x here, then there will be no problem. If we write 2x at a place of y, then no issue. Why? Because it's saying that y equal to 2x. You see here, y equal to 2x. So if we write 2x instead of y, is this crime? No, this is not a crime. We can write this. Okay, and this x and y belongs to n, means this x and y belongs to this n. Okay, so let's make a relation r equal to x. Suppose we took 1 first, 1, then y will be 2 into 1 is 2. Now if we take 2, then it will be 2 into 2 4. If we take 3, it will be 3 into 2 6. If we take 4, then it will be 4 into 2 8, and so on till infinity. I hope this is clear to you. Now example 11, examine each of the following relation. Okay, we have some relation here and we have to examine that. Given below, and state each case giving reason whether it is a function, or we have to judge. Okay, we got a chance to judge someone. The first candidate is r equal to 2 1 3 1 4 2. Look, I am very weak in math. Okay, so whenever I see something like that, I immediately do one thing. I draw two sets, so I can just represent the first element, the first pair, order pair. The first element of order pair is like 2 3 and 4, and the second one is 1 and 2. Now we see in first one we have 2 and 1, 2 2 1, 3 2 1, 3 2 1, 4 to 2, 4 to 2. So you see there is a input and it have some output. Input output, input out. There is nothing like for the one input we have a two outputs. Okay, so if there is only one image of a element, if we have only one image, here you see, if we have only one image, we have only one image, then we can say this is a function, right? Okay, now the second one. So let me just make it smaller so we can make another question here. Okay, now question number 2. Okay, so we have another candidate to judge. So r equal to 2 2 comma 2 4 3 3 2 4 3 3 bracket and 4 4. Okay, 4 and 4 close. So immediately I will draw arrow diagram. I hope you remember what is arrow diagram. So we have 2 3 and 4. You see 2 2 3 4. So if we have a 2 2, we don't need to write it's 2 time. Okay, now 2 4 3 4, 2 4 3 and 4 is already written. So for the first one 2 to 2, for the second one 2 to 4. Oh my god, what is this happening? You see here, for single input there is two outputs, output 1 and this is output 2. So we don't need to see further. We know this is not a function. What we see? Not a function, not function. Thank you so much. Now we can close this. Okay, so this candidate is rejected. Okay, please go there. Now the third one. Okay, so let's judge the third candidate. So third one is r equal to 1 2 2 3 3 4. Oh my god, this is long. So if we just remove this and just remove it, and let's do something like this. Just keep it here so we can get a full width to write this. Okay, so this is the third one. R equal to, let me just write on a super fast mode, 2 3 and 3 4 4 5. Actually we don't need to write this again because already we have typed it. Okay, so we can directly take it from there, but okay, no issue. Okay, 1 2 2 3 3 4 4 5 5 6 and 6 7. So let's quickly draw the arrow diagram. No, this is not looking good actually. I need to remove this. Yeah, now good. So we have 2, 1, 2, 3, 4, 5, 6. 4, 5, 6. The second 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. For every input we have a single output, or we can say we have a single image of every element of A, right? Suppose this is A and this is B. Okay, so this is a function. Actually I am writing this with the red one. So this is a function. Okay, next. Now we have completed the first one, that is function. What is function? Now the second one, real and real valued function. Okay, so I think this is a part of function only. Let me see here. Yeah, so this is a part of function, real function and real valued function. So what is real? Real means real, and real valued. What is the difference? I just want you to think with your own. And now if you are completed with your thinking, let's see. Before we start to think what is real, or before we start to understand what is real or real valued function, keep in mind that we are talking about the real numbers. Okay, what we are talking about? We are talking about the real numbers. And what is a real number? Real number is any number that you can imagine. Okay, that is a real number. So if you say 1, this is a real number. 1.5, this is a real number. 0.25, this is a real number. -3, it's a real number. 0, it's a real number. So √2, √10, pi, everything is a real number. Okay, next. You see here, real number and real valued number. So we know about the real numbers, right? Okay, we also know that if we have two set, what happens here? What happened? This is A and this is B. So for every input we have a single output. For every input we have a single output. For every input we have a single output, right? So what it's saying, that real function, in real function the input will be a real number. Okay, and in output also we will get real number. So if your function is real function, it means it will take a real number as an input, and it will be give you a real number as an output. Okay, but for the real valued function, input can be anything. Okay, anything, a name or a gender or anything, right? But the output should be, it must be a real number only. Okay, so this is the difference. In real function, the input will be a real number and the output will be a real number. But in the real valued function, we only focus on the output. Okay, if output is a real number, then this is a real valued function, right? Okay, let's see the example here. It's saying that let n be the set of all natural number. Okay, let's quickly draw. This is n. And all the natural numbers are here, 4, 5, 6, 7 and so on. Define a real valued function. Okay, so the output should be a real number. If function such that n belongs to n, means n to n, this function will be created with n to n, means we have to copy this. We have to copy this. Okay, we have to copy this. So we have to make a relation between these two sets. Okay, these two sets. Okay, now it's saying by fx. What is fx? Fx, if function x equal to y. Fx means y means fx. Okay, so fx equal to 2x plus 1. So if we have x equal to 1, then y equal to 2x plus 1, that is equal to 2 plus 1 equal to 3. Okay, so x equal to 1, then y equal to 3. Why 3? Because we have to satisfy this condition, 2x plus 1. So 2 into 1, 2 plus 1, 3. Okay, so we have to make in this form. Using the definition, complete the table given below. So we have x1, then what will be the fx? F of 1, function of 1, it will be 2 into 1 plus 1, that is 3. Now the second one, if we have 2, then if we are taking x equal to 2, then what will be the output? Can you think? I just want you to just write in comment below, so you can check whether you are thinking, the way you are thinking is right or not. Okay, so we have 2, it means we have to do 2x plus 1, 2 2 is 4 plus 1 5, 3 2 is 6 plus 1 7, 4 2 is 8 plus 1 9, 5 2 is 10 plus 1 11, 6 2 is 12 plus 1 13, 7 2 is 14 plus 1 15. Okay, so this is the answer. Let's move. Now we have reached on the second topic, some function in their graph, right? So first of all, we have the first graph, that is called identity function. Okay, so what is identity function? Let R be the set of all real number, means we have a set and there is all real numbers, maybe anything, maybe 1 or 2 or 0.5 or 2 by 3, anything, right? So there will be some numbers. Define the real valued function if such that R to R, means we have two functions here, R to R, here R and then again R. Okay, so we have to take elements from this to this, means for example, if this is a, this is a, no, only a, no a dash, and this is a dash. So we have to make relation, we have to make function R to R by y equal to fx, means y, actually instead of y you can write fx. And what is fx? Fx equal to x. What it means, let me just show you. You see graph here. Okay, when we are taking 2 in x, then what is y? 2. When we are taking 4, then what is y? 4. Okay, when we are taking 6, then 6. So let me just make a graph here. Suppose this is 1 2 and 3, then 1 2 and 3, then -1 -2 and -3, -1 -2 and -3. So if we will take x equal to 1, then what will be the fx? It will be 1, right? If you take 2, then it will be 2. If you take 3, then it will be 3. If you take 4, then it will be 4. So 1 and 1, 2 and 2, 3 and 3, 4 and 4. If you take -1, then it will be -1, -2, -2, -3, -3, -4, then -4. Why? Because y is saying simply x equal to y. If you take 1, then y will be automatically 1. So you see, the graph will be something like a straight line, and this is the same explained here, right? Now next one, second one, constant function. Define the function f such that R to R by y equal to fx equal to c, means we have to just take some anything constant. You see in this graph, okay, I want you to just focus and see and observe what is the what is this line is about. You see on the y-axis, on y-axis we have something constant 3. When we taking x, if this is the x and y, okay, so if we are taking x equal to -8, then y is 3. Then we are taking -6, then it is 3, -4 3, -2 3, 0 3, x equal to, see here x is 0, then 2 3 4 3, means the value of x is only changing but the y is constant 3. So this is the same, and we have represented this with a line, right, with this line. So this is a constant function, very simple. Whenever we have fx equal to something fixed, not variable, then this is called constant function. And for the constant function, graph will be formed with parallel to the x-axis. So this line is parallel to x-axis, right? In the identity function, the graph was forming like it was crossing a straight line, right? But in the constant function, we have created graph with a x-axis, a line with a parallel to x-axis. Now polynomial function, very simple. A function, if R2 R is said to be polynomial function if for each x in R, for each x, for x in R, y will be fx, that is equal to a0 plus a1x plus a2x square plus a3x cube. Simply the fx will be a polynomial function like x square plus x plus 1 or x cube or x square or x square plus 1, something like that, okay? And the graph we will make, the graph will be created like, let me just show you. Suppose you have taken x and y, right? So if you take fx equal to x square, okay, so if you take 2 it will be 4, if you take 3 it will 9, if you take 4 it will be 16, if you take 5 it will be 25, if you take -2 it will be 2 if you take -4 it will be 16, right? And what will be the graph? Let me just open this, and we have number x 5 and y 25, right? So suppose this is, let's make for the 5 and 5, 25, and what is the interval here? 2 3 4 5, and for y 4 9 16, so we have to take 1. So suppose this point is 25 24 23 22 21 20 19 18 17 16 15 15 14 13 12 11 10 9 8 7 6 5 4 3 2 1 0, -1 -2 -3 -4 -5, right? And on the x-axis we have 1 2 3 4 5 6 7 8 9 10, -1 -2 -3 -4 -5 -6, okay? So I hope now this is perfect, I think. And for this line we have to also draw. Let me just open the scale. Yeah, so the line will be, something like that. Okay, so now we have just let me copy this so we can draw the graph of our equation. We have to make a graph of this, make a copy, paste it here. Yeah, what is doing, man? Paste. Okay, so x2 and y4, so this is a point. Okay, this is a point, x2 y4. Then 3 and 9, 3 and 9. Okay, then 4 and 16, so this is 16, 1 2 3 and 4. I think I have done something wrong here. Yeah, definitely. Okay, so 2 and 4, this is the second and this is the fourth one, and third and 9, 4 and 16, 5 and 25. So 1 2 3 4 5, this is the 5. Okay, if you see in the minus 2, x minus 2 and the plus 2, so you see this graph will not go below the x-axis. It will be not cross the x-axis. Minus 4 16, minus 4 1 2 3 4 and 16, you see here. Okay, and if we take another number like minus 3, then we will get 9. If we take minus 5, we will get 25. So here minus 3 and 9 will be here, 5 and 25 will be 25, 1 2 3 4 5 here. So you see this graph is forming in the shape of U actually. You see something like that. If you take 0, then 0 to 0 0. Okay, let's see the, so this is the polynomial function. Okay, we have to take any function to represent our graph and make the all values. Okay, example 3. So what is example 3? Define the function r to r by y equal to fx xx square. Okay, so we have already checked for the fx equal to xx square. Okay, and minus 4, then it will be 16 9 4 1 0 1 4 9 16, and the graph will be something like this. Here is x-axis, this is y, this is x, this is x dash, this is y dash, right? Now example 14, draw a graph of the function f r to r defined by fx equal to x cube. So in this case what we have to do, we have to just take, if we have x equal to 1, then we have to take x to cube 1, if 2 then 8, if 3 then 27, and we have to make a graph. Okay, so 1 to 1, 2 and 8, 3 and 27, you see. Now if we just make a opposite, okay, minus 1 minus 2 and minus 3, so it will be minus 1 and minus 1. For minus 1, if we make a cube, minus 1 minus 2 minus 8 minus 3 minus 27. So this line can also go below the x-axis, because minus 1 minus 2 and 8 and minus 3 and 27. So this can also cross and make this type of graph also, right? Okay, so if there is yeah, so for the polynomial we have to see what is the given equation, and as per this equation we have to find out the value of fx. Okay, that is simply y, and we have to draw the graph over there. So the fourth one, rational functions. Okay, so rational functions are of type of fx by gx, where fx and gx are polynomial function of x defined in the domain where gx is 0, means x by y, where y cannot be 0, right? And this x and y is a form of x square by x, something like that. Okay, I hope you are understanding this, right? Okay, so now see, now rational functions, right? So you see here, if you have, for example, there is a table. Okay, there is a table. Let me see if the example we are having here. Yeah, so we have example to explain what is rational functions. So you see here, we have an example, define the real valued function fx r minus 0, means we have to subtract for the all real numbers. If there is set of all real numbers, we have to subtract the 0 from there. Okay, why? Because we have condition that gx cannot be 0. Okay, so if from r we remove the 0, if you don't give input as a 0, then there is no chance of getting output as a 0 as well. That's why it's written here. Let me just clear so you can see in a better way. You see here it's written r equal to fx such that r minus 0, means in input in the first set there should not be any 0. Okay, if there is no 0, then there is no chance of getting any set any output which have a 0, right? Let me just prove this. Okay, give me a second. Okay, so x belong to r and that is not 0. Okay, it belongs to r but except 0. Complete the table given below using the definition. What is the domain and range of the function? Okay, so if we have x equal to minus 2, then it will be 1 by x, that is minus if we have x means minus 2, so 1 by 2 is 0.5 and in minus. Okay, so 1 by 1.5, it means 1 we have to divide with 1.5. This is less than this is less, so we will make 0 point and we will give it 10. So 6 9, so I think 6 ja it will be 9, then again 10. So we see it will repeat the same value, then we can just write 0.67. okay, so this will be 0.67. 1 by 1 minus 1. 1 by 0.5 means 1 by 0.5, 2 ja 2. Okay, 1 by 0.5 means 1 by 2. It means 1 by 1 into 2 by 1. It means 2 by 1. It means 2. Okay, so I have just give you two methods to do this. Okay, this is the second method. Okay, nothing else. Don't be confused. If you have any confusion in this, just erase this. It does not matter. You have to just find, if you will divide 0.25 1 with 0.25, what you will get? You will get 0.5 then 2, and here you will get 4. Why? Because 0.2 4 ja 1. Okay, 0.5 it will be in minus, then 2 1 1.5, then it will be, this is in minus, right? It will be in plus 0.67. Why? Because we are dividing 1 with 1.5, so this is less, we have to take 0 point, and it will be 10, then 6, then 7, and this is positive. Okay, so 1 by 2 equal to 0.5, right? 1 by 2 equal to 0.5, right? So this is the table that we have already completed, and if you want you can make a graph on the basis of this, and you can try whether this is what is the form of graph. Okay, so let me just quickly draw this also. Okay, so this is in the form of 0.5. okay, 0.5, 1, 1.5, 2, 2.5, 3. Okay, something like that. So if we have minus 2, 0.5, 1, 1.5, 2, 2.5, 3. So we have minus 2, 1 and 2, 0.5, 1, then 2. Then in y we have 1 by 2, that is 0.5. Okay, so this is 0.5 in minus. So in plus x-axis minus 2, and this in minus 0.5. so the point will be here. Okay, then x minus 1.5, and y it will be minus 0.67. so this is 1.5, and it will be somewhere here. Okay, then we have minus 1, and this is here. Then we have minus 0.5 and minus 2, so it will be somewhere here. Okay, then we have 0.5. okay, 0.25 and 4, 0.25 and 4, somewhere like this. So you see this is bending, right? This is bending. I have not draw it perfectly, but if you will see, it's bending like this. Okay, and here I think it will be like this. Why? Because we have started with a small x and the higher y, so x will be less and y will be higher, so it will be like this. I think you can draw with your own because you have the value, and I have just missed it here, so let me just write it nicely. Okay, here it will be minus 0.5, minus 0.5, here minus 0.67, right? So on the basis of this data you can make a graph, and you can see what is the image of that graph. Now the modules function, the function if such that R2 are defined by fx equal to mod. Before we continue, I just want to tell you that x mod equal to, if there is minus 2, then the mod of minus 2 will be 2 only, and if there is 2, then mod of 2 will be 2 only. So if you put anything in mod, if it's negative, it make it positive. That's it. This is its capability, or you can say talent. So if you put anything in this, it will just make it positive. So it's saying defined by fx equal to x. So if you have a table, everything is about only that if you put something in x, what will be the value of y? If you put something in x, what will be the value in y? Everything is about this only. So for each x belongs to R, means all the x here it will belong to R, is called a modulus function for each non-negative value of x. Fx is equal to x, but for negative values of x, the value of fx is the negative of the value of x. Example, fx equal to x and x is greater than equal to 0. If minus x, then x is negative 0. What does it means? Can you just understand and tell me? So it's saying that fx is nothing. Yeah, so fx is nothing, but if you put anything in x, whether this is minus or plus, no matter. Let me just clear this, it's not looking good, I know. Okay, so what is the point of this definition? It's saying if you put x equal to 2, then y will be mod of 2. So if it's positive, then there will be positive only. If you put minus 1, so mod of minus 1 will be 1, so it will be give you 1. If you put minus 3, then it will give you 3. If you put 5, it will be give you 5. If there is any negative number, it will convert in positive. Okay, if there is 4, then it will be give you 4. And the graph will be something like that. If x is 2, suppose this is 2, then y will be 2 only. If there is minus 1, x is minus 1, then y will be 1. If there is x is minus 3, suppose here, then y will be 3 only. So you see, if we make graph, it's something like that. Okay, so this is not crossing. Why? Because mod is preventing y, to become negative. So there will be no representation here on the y-axis. It will be only in 3 axes, minus x, plus x, and plus y, positive y. Okay, next, sixth one, signum function. This is very interesting. You see, the function if such that r to r defined by fx, 1 if x is greater than 0, 0 if x is equal to 1, means whatever you give the number, a machine, suppose this is a machine, you give any number, and in output it will tell you whether this is negative or 0 or positive. This is its speciality. Okay, you give any number 5, and there is a fold here. Okay, it's not seeing whether this is positive or negative. It will just tell you this is negative or positive or 0 or positive, right? Why this happening? What is the logic behind this? Can you just imagine? So the logic behind that is, whenever we do signum function, then if we have x, suppose we have x and y, so x, suppose we have minus 3, so what it say, fx equal to mod of x by x. Okay, you understand? Do you understand? Okay, let me tell you what. If there is minus 3 as an input, then what will be the mod of 3? Minus 3, it will be 3. It will be 3 by minus 3. Okay, 3 by minus 3. This is minus 1. Okay, so the answer will be minus 1. This is a negative number. Suppose we have given 2, then it will be just take 2 mod by 2. So it will be 2 by 2. Cancel 1. So answer will be 1. Suppose you give it 0, then mod of 0 by 0 equal to 0 by 0 equal to 0. So this is a 0. Yeah, so very simple. Now let's move on the seventh one, greatest integer function. This is also very interesting. Let's quickly read the definition. The function f such that f to f defined by fx equal to this. And you know what is, how we read this symbol with x? Any of you, if you know how to read this, just pause this video for a while and think about it, then how we read it, right? Okay, so while you are reading, let me just tell you what is the meaning of this. Okay, x belongs to x, assume that the value of the greatest integer less than or equal to x. Suppose we have a value, means greatest integer value, we have to find greatest integer value, right? And we have given 8.99, so the greatest integer value will be 8. If we have given 9, then it will be 9. Why? Because here it's written x belong to r, assume that the value of greatest integer less than or equal to x. Whatever we have given the x, it will be less than or equal to, less than or equal to given x, right? So this is the all about this, nothing else we have to understand in this. Okay.